guys, welcome to the channel. So today we are going to talk about the concept of chromophores and auxochromes. So actually the concept of chromophore came from imparting color. So if we look at the range of 400 to 800 nanometer or millimicron, then the compounds which show absorption in this range, that is from 400 to 800 nanometer or millimicron, they appear colored to the human eyes. Earlier, chromophore was considered to be a system which was responsible for imparting colors. For example, nitro groups in nitro compounds are responsible for showing the yellow color, and the aryl groups in the azo compounds give color to the azo dyes. But now this term chromophore is used in a much broader way. That is, it is considered as something which is isolated, covalently bonded. So these are isolated covalently bonded groups. So these will be termed as chromophores, and the absorption due to them will occur irrespective of the fact that color is produced or not. So now we will discuss some of the examples of chromophores. So examples of chromophores will be like double bond, triple bond, benzene, nitro, carbonyl. These are all the examples of chromophores. Now if we talk about the auxochromes. So auxochromes are basically saturated compounds. So if we talk about the auxochromes, so these are saturated ones. For example, CH3, Cl, NH2, NHR, OH, NR2, SH, etc. So these are all the auxochromes. Now when auxochromes they get attached with chromophores, when these auxochromes attach with any of the chromophores, they extend the conjugation. For example, if we have some sort of a chromophore, suppose I take this benzene. This benzene is a chromophore. It has lambda max of 254 nanometer. Right? This has lambda max of 254 nanometer. Now if I attach one auxochrome, suppose if I attach this NH2 with this benzene like this, so this is having one lone pair. Now in this case, this is the auxochrome and this is the chromophore. Now here lambda max will be 280 nanometer. Why? Because of more resonating structures. Benzene will be having the two resonating structures, right? Like this. And this will be having multiple resonating structures. First of all, this will go here. This double bond will go here, right? Now this goes here and this goes here. After that, this continues on and on, right? You can make the resonating structures by your own, but the main point is that after attaching this particular auxochrome with this chromophore, the resonating structures have been increased. If resonating structures are increased, that means there is stabilization of energy. Stabilization in energy means lambda max increases. Okay, one more thing I wanted to tell you guys. What is lambda max? Many people have this misconception about lambda max. What is lambda max? Lambda max is not maximum wavelength. It is wavelength at maximum absorption. Now, what do I mean by that? It is wavelength at maximum absorption. So suppose if I take certain molecule and I take the UV spectra of it. Suppose I take certain molecule and I take the UV spectra of it and I get a spectra like this. Right? This is the absorbance and this is the wavelength. So the lambda max for that particular molecule will be somewhat here. Here whatever value I get, suppose this is at 230 nanometer. So this is not the maximum wavelength. See, this is not the maximum wavelength. This is the value of wavelength at maximum absorption. The point at which I get maximum absorption. At that point, whatever wavelength I am getting, that is the maximum wavelength. So lambda max is nothing but it is the wavelength at maximum absorption. That is the wavelength at which after scanning you get the maximum absorbance. At that particular point, whatever wavelength you are getting, that is the lambda max, right? Now I'm keeping this video short because I want to start fresh with the new topic, which will be the absorption and intensity shifts. So in that video we will discuss about the hyperchromic, hypochromic, bathochromic, hypsochromic shifts. So this is all about this video. In next video we will start with the next topic.